1.7 linear inequalities preparation. Linear inequalities in one variable, a linear inequality in one variable. And it just kind of goes over the structure of it. I'm just going to dive right in. And first, we are going to practice on how to graph very simple ones. Okay, so hopefully this makes sense. Now, as long as x is on the left, where the arrow points is where the where you're going to shade this in, where you're going to shade in the on the number line. How to graph this. So first, we're going to plot the -5. The -5 is over here on the left. We're going to plot that right there, right? And then, because it says x is greater than -5, greater is to the right. Greater is to the right. And you can see it points the same direction as the little inequality symbol. So now, because this has the inequality without the equal part, we are going to use a parenthesis like that, and then we just shade all this in. Okay. Now that we finished the graph, but they also want to write it in interval notation. Interval notation. So based upon what we have, we just bring it down. So you notice that I bring down the parenthesis. I'm going to put the -5 inside of it. And since it goes off to the right, there's an understood or implied positive infinity there. If you go off to the left, it's understood or implied negative infinity there. And you go up to positive infinity. And there you go. That's it for that one. So let's try the next one. Next one, first we're going to plot the 10. All right, so 10 is over here. Now I do want to point, well, let's do the 10. So we do the 10. 10 is going to be here somewhere. Because the arrow is pointing towards the left, we know less than is to the left. We're going to do a parenthesis, and we are going to shade it in all the way to the left. And if you go to the left, there's an understood or implied negative infinity there. Okay, so parenthesis, we put the negative infinity there. And then we go all the way up to a 10, and we end with a 10 and then a parenthesis next to that. There you go. Now, technically, whenever you have these inequalities without the equal sign, it cannot be equal to 10. So this interval is negative infinity to 10, but not including 10. And the first one over here is -5 to infinity, right? But it's -5 not including -5 to infinity. So whenever you use these parentheses, it does not include the number next to the parenthesis. Now, this is different because this is x is greater than or equal to -3. So we plot the -3 like this. Then, because the arrow is pointing towards the right, we know it's going to open to the right, but because it has the equal part, we are going to use a bracket. So same kind of procedure, but instead of a parenthesis, we are using a bracket. Then if we want to put it in interval notation, we put the -3 within. Now, because you're going off to the right forever, there's a understood or implied positive infinity there. And because you never reach infinity, you're going to put a parenthesis next to the infinity. Now, it's very important to remember that whenever you have an infinity symbol, you are going to have a parenthesis next to it. You're never going to have an infinity, well, on these, you're not going to have any infinity symbol with a bracket next to it because you're not equal to negative or positive infinity. So that one's wrong. And this one, that's okay. So again, whether you see a negative or positive infinity, whenever you're writing interval notation, you're going to have a parenthesis on it. So let's try the next one. Next one is x is less than or equal to 8. First step, we are going to plot the 8. Next step, because it is less than 8, and because it has the equal sign part right there, we're going to use a bracket opening up towards the left. And because going to the left forever gives you negative infinity, so when we put it in interval notation, we're going to start with the negative infinity on the left. We're going to move on to 8, and because you see right here you have a bracket, you're going to put a bracket next to the 8. Okay, let's try another one. Now, this one right here is a little more complicated because we have 3 less than x. So one thing you can do is you can actually modify it, but let's do it without modification first, and then I'll modify the inequality, and we'll do it that way. So I'm going to do this 2 different ways. So first, we plot the 3, but it's saying 3 is greater than x, or to read it from right to left, you'd say x is less than 3. X is less than 3. Well, x is less than 3 is going to go to the left. And because this is an inequality without the equal sign, we're going to use a parenthesis. That looks terrible. That's supposed to be a parenthesis, so we just shade all that in. Because we go to the left forever, we have a negative infinity. So when I put an interval notation, I start with negative infinity on the left, and I go all the way up to 3 on the right with a parenthesis. Now, if you find that confusing, just flip it so the x is on the left side, flip the inequality, and then rewrite the 3. So you can flip the entire inequality to have the x on the left, and that might make it a little easier to interpret the inequality for purposes of graphing and for writing it as an inequality. So it might be a little easier on you that way. All right. I did write down kind of set builder notation here, interval notation, and graph. We haven't been asked to do any set builder notation yet, but whenever we do get there, you can reference this. So we're going to solve each inequality, graph the solution set, and write the solution set in interval notation. Now, since this is not solved for x, you don't have x on the by itself on the left or right, your first step on this one is you're going to solve for x. Okay, and you solve it just like a linear inequality, except if you divide or multiply both sides by a negative, you need to flip the inequality. And I'll do an example of that later. Okay, so right now we're trying to get all the x's on one side. So we have 3x on the left, and we have 2x on the right. To get rid of those 2x's on the right, we subtract 2x. Whatever we do to one side, we do to the other. So what we end up with is 7 plus x is greater than or equal to 5. Next, we want to get all the constants on the other side. So I get rid of this positive 7 by subtracting 7. Whatever we do to one side, we do to the other, giving me x is greater than or equal to negative 2. Okay, now we're going to plot the negative 2. Negative 2 is right there. Because as the equal part, we know we're going to be using a bracket. And since it is x is greater than or equal to, and the arrow is pointing towards the right, we are going to open the bracket towards the right and just shade this in. Okay, now, based upon this, we're going to drop down the bracket and put the negative 2 inside of it. It goes off to positive infinity, so we write the positive infinity, and because you never reach infinity, you have the parenthesis. And that's it. Okay, let's try a couple more. Okay, so in this one, we want to get the x by itself by undoing the multiplication of x by 3. Whatever we do to one side, we do to the other, so we divide the other side by 3 as well. Gives me x is less than negative 6. Now notice that I divided a negative by a positive, and the inequality did not flip. That's correct. It's only when you divide both sides by a negative, or you multiply both sides by a negative, then you flip the inequality symbol. So this one, so far so good. Next, we're going to plot the negative 6. We plot the negative 6 right there. We say x is less than negative 6. And since it does not have the equal sign, it's only the inequality. It's only the less than. We're going to use a parenthesis, and we just shade it in. Because if you go to left forever, you end up with negative infinity. We're going to have negative infinity over here. So if I write this, we're going to have negative infinity within parenthesis, negative infinity. Goes off to the right to a negative 6. And we end with a parenthesis. It is very important in interval notation to write the smaller number on the left and the larger number on the right. Okay, next problem, we need to undo the multiplication of t by negative 4 by dividing by negative 4, and whatever we do to one side, we do to the other. Cancel, cancel, we end up with t is less than or equal to positive 8 divided by negative 4 is negative 2. But notice that I had to flip the inequality symbol. Okay, now we're going to plot the negative 2. Negative 2 is right there. It says t is less than or equal to, and because the equal part, we're going to have a bracket instead of a parenthesis, and because the arrow is pointing towards the left, or because it's saying t is less than, which is to the left, we are going to make the bracket open up towards the left, and we just shade all that in. Because it's going off to the left forever, we have a negative infinity there. So we are going to say negative infinity all the way up to negative 2, bracket, parenthesis.